Hello everyone, welcome back to JEE Physics PYQs. Let us solve this JEE Main 2026 problem based on torque and rotational equilibrium. We have a uniform rod of mass 250 gram and length 100 centimeter. It is supported at the 40 centimeter mark. A 400 gram mass is suspended at the 10 centimeter mark. To maintain the perfect rotational balance of the rod, we have to find the mass to be suspended at the 90 centimeter mark. First, we have to identify the pivot. The rod is supported at the 40 centimeter mark here. So we take this point as pivot. For rotational equilibrium, the net torque about the pivot must be 0. So clockwise torque must equal anticlockwise torque. Let us identify the forces and coordinates. Let us redraw the figure. A rod of 100 centimeter length. The pivot is at 40 centimeter from the left. 400 gram weight is located at 10 centimeter from the left. So its distance from the pivot will be 40 minus 10, 30 centimeter. We have to find this mass which is suspended at 90 centimeter from the left end. Therefore, its distance from the pivot will be 90 centimeter minus 40 centimeter, 50 centimeter. Mass of rod is 250 gram and the rod being uniform, its weight will act precisely at the geometric center of the rod at half of 100 centimeter, that is 250 gram. Rod's weight will act at 10 centimeter from pivot. Now we will set up the torque equilibrium equation for the rod to maintain perfect rotational balance. The net torque about the pivot, this must be 0. This means the total counterclockwise, that is left side torque, must be equal to the total clockwise or right side torque. From the figure, 400 into 30 equals 250 into 10 plus m into 50. 50 m equals 12,000 minus 2,500, 9,500. Therefore, m will be 9,500 upon 50, cancelling 0. 5 ones are, 5 nines are, 5 zeros are, 190 gram. So therefore, this mass to be suspended at 90 centimeter mark. This mark to maintain perfect rotational balance is 190 gram. So the correct answer option here is B, 190 gram. Quick JEE trick for these balancing problems: don't try to calculate forces unnecessarily. Just remember, choose the pivot, find each distance from the pivot, identify clockwise and anticlockwise torques, equate them, and for a uniform rod, always remember its weight acts at its midpoint. This was a simple application of rotational equilibrium, but the main trap was correctly accounting for the torque due to the rod's own weight. Keep practicing JEE Main rotational motion numerical PYQs. See you in the next problem.